Lesson 613, which was interpreting reaction time data. So students, you were to collect reaction time data and create a line plot. Then compute with decimals to identify typical reaction times and to estimate a total class reaction time. So our home link has some data. Your directions say, Garrett tried the grab-it gauge experiment with his left hand. He recorded his results on the line plot below. Use the data to answer the questions. So number 1, I think you can do on your own, and it said which time or times came up with the most often for Garrett. So which one has the most X's on it? There may be more than one. Write Garrett's reaction time in order from fastest to slowest. You need to mark every single data point. So there are 1, 3, 5, 7, 9, 10. 10, so I should see 10. So I know his fastest time was 14 hundredths of a second, then 15 hundredths, and 15 hundredths again. So these are the ones I've used, and then 16, and then 16, and so on. What is the difference between Garrett's fastest time and his slowest time? Your key word here is difference. Difference means to subtract. You are subtracting. So we always start with our biggest number. So 19 hundredths of a second minus 14 hundredths of a second. What is Garrett's evened out reaction time? Record your calculations. So to do that, you need to add all of them up and then divide by the total, which is 10. And then what would you say is a typical reaction time for Garrett's left hand and why? And explain your answer. Your practice is to subtract, show your work on the back of this page. So first we need to estimate. So I have 5 and 63 hundredths minus 2 and 19 hundredths. I'm going to round my 5 and 63 hundredths to 6 minus 2, and that's going to give me 4. So 5 decimal point 63. I'm going to rewrite my problem vertically so it's easier. 3 minus 9. I know I can't do it, so I borrow from the 7. My 3 turns into a 13, and my 6 turns into a 5. 13 minus 9 is 4. 5 minus 1 is 4. And 5 minus 2 is 3. Do number 7 on your own.